Hi, welcome. Myself, I am Lokita GS, studying in the Department of Artificial Intelligence. Today's subject is DSA, subject code is BCS 304. The topic which I am going to cover today is optimal binary search trees. Instructions. Optimal binary search trees are the type of data structures used for efficient searching. They are commonly used when the search operations are frequent and need to be performed quickly. The goal of an optimal binary search tree is to minimize the average search time. This is an example of searching in binary search tree. Search for 7. Now let us look at the diagram and search for the number 7. First, we are comparing, is 7 smaller than 20? Yes, then go left. So, again we are comparing, is 7 greater than 5 or lesser than 5? It's greater than 5, so we will go right. Again, we are comparing 15 with the 7. Is 7 less than or greater than 15? We get to know 7 is less than. So we'll go to left node. Again, compare it with 9. Is 7 less than or greater than 9? 7 is less than 9. So we will go to left node and we found the 7 in the binary search node. If the value is smaller, we always go to the left node. If the value is greater, we always go to the right node. Definition. An optimal binary search tree is a binary tree where the expected search cost is minimized. The expected search cost is the weighted average of the cost of searching for each key weighed by the respecting probabilities. The cost of searching for a key is defined as the number of comparisons required to find the key. Optimal binary search tree. As we know that in binary search tree, the nodes in the left subtree have lesser values than the root node, and the nodes in right subtree have a great value than the root node. We know that the key value of each node is the tree, and we also know the frequencies of each node in the term of searching means. How much time is required to search a node? The frequency and the key value determine the overall cost of searching a node. The cost of a node should be less. The time required to search a node in BST is more than the balanced binary search tree, as the balanced binary search tree consists a less number of values than the BST. There is one way that can be reduced the cost of binary search tree in known as an optimal binary search tree. This is an example. The below given is an example for another binary search tree where if you want to find the value 10, we will compare, is 10 less than 40? Yes, it is. So we'll go to the left node and again we will compare, is 10 less than 20? Yes, it is. So we'll again go to the left node and here we find 10. Dynamic programming approach. The dynamic programming approach is commonly used to construct optimal binary search trees. It involves breaking down the problem into smaller subproblems and solving the solutions of these subproblems to construct the optimal binary search tree. The dynamic programming approach ensures that each subproblem is solved only once, leading to efficient construction of the optimal binary search tree. Computing by optimal binary search trees. Computing optimal binary search trees involves determining the optimal structure of the tree and the associated cost. The algorithm starts by computing the probability of each key and the probability of each subtree. Using these probabilities, the algorithm then constructs the optimal binary search tree recursively. Steps to construct optimal binary search trees. Determine the probability of each key and the probability of each subtree. Create a table to store optimal costs for each subproblem. Iterate over different subproblem sizes and compute the optimal cost for each subproblem. Example. Let's consider an example. Here we have keys with probabilities A 0.2, B 0.1, C 0.15 and D 0.05 and E 0.3. We also have dummy keys with probabilities DO 0.05, D1 0.1, D2 0.05, D3 0.05 and D4 0.05 and D5 0.1. We can use the dynamic programming approach to compute the optimal binary search tree for these keys. Example, the computed optimal binary search tree for the example keys would have this structure. The second bullet, the third bullet. Advantages of binary search tree. The optimal binary search tree offers efficient search operations within the minimum average search time. They are particularly useful when the search operations are frequent and need to be performed quickly. The dynamic programming approach used to construct optimal binary search trees ensures efficiency and optimal results. Applications. Optimal binary search trees find application in various fields such as information relatives, compilers, constructions, and database system. They are used to efficiently search for words in a document, search for variable in a document, or search for records in a database. Optimal binary search trees are also used in the construction of efficient data structures like B trees. Conclusion of optimal binary search trees. Optimal binary search trees are an important data structures for efficient searching. They offer a way to minimize the average search time by constructing a binary search tree with the optimal structure and costs. The dynamic programming approach is commonly used to construct optimal binary search trees efficiently. How good is a binary search tree? It is a balanced binary tree and a sequential of queries. Thank you for watching my video. Please do like, share, subscribe.